Welcome, everyone. Thank you for being part of this program because I know you have been following us. And today we are still on the special revision series for WASI, NECO SSC, and UTME candidates. This is a special edition of science tutorial because we are trying to use this edition to prepare our students as far as these exams are concerned. We'll be looking at this different subjects: mathematics, physics, chemistry, and biology. So today we have physics and we are looking at measurement. Remember, we have started measurement already on this series, and we have looked at the basic terms associated with measurement, talking about quantities, dimension, and units. We mentioned the fundamental quantities and derived units. We also described dimension and units, and we also looked at various dimensional analysis, that's finding the dimensions and units of derived quantities. It's important that you watch the previous videos on this series. So today we're going to look at the last aspect that we must consider in measurement, and that aspect is finding constants in arbitrary dimension. So that's the aspect we're going to look at, and then we'll now conclude and move over to another topic on this revision series. So we are going to look at finding constants in an arbitrary dimension. Or in arbitrary dimensions. So because it's not just going to be one, in arbitrary dimensions. Okay. What do we mean by arbitrary dimension? If we have a dimension that is not well specified, that still contain unknown, then unknowns, that particular dimension is said to be what? Arbitrary dimension. Let's take, for example, we have this. L raised to power b, t raised to power maybe c over 2. C over 2 is 2. Now this is an arbitrary dimension because we don't know this. Maybe someone may tell you that this is the dimension of work. That is the dimension of work. Now, this is not the dimension of work, actually. It's not the actual dimension, because if it's the actual way, there is a number that's supposed to be here, there is a number that's supposed to be here, there is a number that's supposed to be here. But these numbers have been replaced with what? Letters. So the dimension is not the actual, rather it is referred to as what? Arbitrary. So when you have a dimension that is not well specified, then that dimension is what? Arbitrary dimension. And our business is to find a constant in those what? Arbitrary dimensions. That's our business. That's what we want to consider in this last aspect of measurement, as it concerns quantities, dimensions, and what? Units. So how do we go about finding these constants in any arbitrary what? Dimension? That's our focus. How are we going to do that? So we say to find constants in a given arbitrary dimension, we take these steps. What are the steps? 1. Take note of the dimension. Take note of the dimension. Take note of the dimension. That's the arbitrary dimension now. Take note of the arbitrary dimension. Obtain the actual dimension of the quantity. Then compare the arbitrary and actual dimension, and equate the powers of similar terms, then finally solve for the constants or the unknown now, because those constants are unknown. This is just grammar. We say to find constants in a given arbitrary dimension, we take these steps. One, take note of the word arbitrary dimension, then obtain the actual dimension of the word of the quantity, then compare what the arbitrary and the actual dimensions and equate the powers of the word of similar terms, then solve for the word for the constant. Just these 4 simple steps will help us to obtain a constant in a given word arbitrary dimension. Let's take a quick example. If maybe we have this one, if the dimension of pressure is m to power s, l to power y, and t to power z, find x, y, and what? And z. If the dimension of pressure is this, find x, y, and z. Now we know that this is not the dimension of pressure because we still have unknown. So this is arbitrary. So if we want to find the values of x, y, and z, that's the constants there, we need to take these steps. So take note of the arbitrary dimension. Let's put it down. M raised to power s, l raised to power y, t raised to power what? Z. We have taken note of that. Okay, they said obtain the actual dimension of the quantity. The quantity of interest here is pressure. So let's get the actual dimension of pressure. We remember that pressure is force over what? Area. So let's get the dimension of pressure. Pressure is force over area. What's the dimension of force? Remember, it's mass times acceleration. You see that? This mass times acceleration. Acceleration is length per time square. Then all upon area. We have obtained this in our previous video, so we have mastered how we can actually obtain the dimensions and units of derived quantities. So area is length squared. Now if you break this down, length can divide this. We are left with m t raised to power minus t all upon l, because length cancels this length times length. That would be what length squared. So if I divide this, I'll be left with l in the denominator there. So if I want to write it like this, in this form now, so I'm going to have m l raised to power minus 1, t raised to power minus 2. That's what I'm going to have. So m raised to power minus 1, l raised to power minus 1, then t raised to power minus 2. So we have obtained the actual dimension of the word quantity, that's pressure, which is this. So this is the dimension given to us. So they say, then compare the arbitrary and the word actual dimension. Where is the arbitrary dimension? This. Where is the actual? This. Compare them. So it means that if this is the dimension of pressure and this is the dimension of pressure, it means they are equivalent. So it means that m raised to power x, l raised to power y, t raised to power z is equivalent to m l raised to power minus 1, t raised to power minus 2. Now they say, and equate the powers of similar terms. Okay, here we have m, here we have m. What's the power of m here? Is x. And what's the power of m here? Is 1, because we know when we have a term and there is no visible power there, that power is 1. So it means that x is 1. Right, so we are comparing this and this, equating the power of similar terms. This term and this term are similar, like terms. So we weight their power. This one is S, this one is 1. So we come to L. What's the power of L? Y here. So we can use this to find L now. What's the power here? -1. That settles it. Then we'll come to T. The power of T here is Z. And the power here is what? -2. So we have found S, Y, and the what? And Z. Very simple. You see, we just took these terms. Take note of the arbitrary dimension. That's what we have done. Obtain the actual dimension of the quantity. We have obtained the dimension of what? Of pressure. Then they said, then compare the arbitrary and the what? Actual dimension. This is the arbitrary, this is the actual. I'm comparing them now. Then the next thing we do is to equate the powers of similar what terms. Equate the powers of similar terms. So this term is similar to this one is similar to this one is similar to this. Equate their powers. The power here is x, the power here is 1. So equate it, that means x becomes 1. The power of this is y, power here is -1. Equate them. Why are we equating these two powers? Because they are powers of similar terms. So the power here is z, the power here is -2. T and t, similar terms. Equate the powers, you have -2. All right. I believe that you are enjoying this. You know, these things are beautiful, very sweet, very lovely, very nice. These are the kind of meal that when you finish eating it in physics, you will want to eat more. So we are going to give another example, and then we'll now maybe drop one for you to actually solve, so that when next we come, we're going to know how far you fared with that particular question, and then we'll now begin our new topic that we need to revise, because we really want to prepare you very well, so that you will not go inside the exam hall and use your question paper as hand fan. You know, some students, they enter in the exam hall, instead of using the question paper properly, they will now use it as hand fan. Some of them will just use it and be fanning themselves at the end of the exam. It will not be your portion. That's not what we are praying for, and that's why there is need for you to actually get involved in this program and also invite your friends to participate. All right, let's take one more question now quickly. Let's take one more. Let's take one more now. Then we can give you one to do. Okay, so question number 2. Given that the dimension of energy is m to power 3a over 2 L to power -2b and t to power -c over 2. Find the values of A, B, and what? C. Oh, beautiful. Given that the dimension of energy is this, find the values of that. Given that the dimension of energy is that, find the values of it. So we still have our steps with us. So to find the constants in a given arbitrary dimension, we take these steps. Number 1, take notes of the arbitrary dimension. So let's take note of that. We have m raised to power m to power of 3a over what? 2, then L to power -2b, and then t to power -c over 2. Okay. We are still on it. Then the next, obtain the actual dimension of the quantity. Wow. What quantity are we dealing with again? We are dealing with energy. You can use any of the expressions for calculating energy in order to obtain the dimension of energy. Yes. You can try that of potential energy, you can try that of of kinetic energy. Any expression you know about energy can actually give you the actual dimension of energy. Some of us will still have it with us even without uh, those expressions. I know that dimension of energy actually is m l square t raised to power minus 2. That's the dimension of energy. But we still need to derive it so that those that maybe you have not watched the other video and you still want to know how we obtain dimension of derived quantities, you may actually watch this and see. We know that one of the energy we usually talk about is potential energy. And potential energy is mass. Let's put it like this: mass times acceleration due to gravity times what? Height. You still remember this? Kinetic energy is half mv what square. That's kinetic energy as a result of motion of a body. This one is as energy as a result of position. So if you are sitting on top of the table now, you have potential energy, that's your position. But if you decide to walk around, your energy will move from potential to what? To kinetic. So energy due to motion is kinetic. Energy as a result of position of a body is potential energy. So if we use this, we can actually obtain the dimension. If you decide to use this also, you also obtain the dimension of what? Energy, whichever one. So I will try this one. You can now verify it using this. Remember, this is a constant, so it will not have any role to play. So it's these two quantities that will actually play role, because half here has no dimension. Okay, now we look at this. What's the dimension of mass? M. G is acceleration due to gravity, and the dimension is length per time what? Squared. And the height, we have said that height, length, breadth, altitude, width, distance, displacement in our second video, that all these they have the same dimension as length. So height is also what? Length. Okay, now you discover that we have length here, we have length here. When length multiplies length, we're going to have length squared. So we have m1 l squared t raised to power minus 2. You see, this is the dimension of energy, and that is this now. That's this. So obtain the dimension or the actual dimension of the quantity, then compare the arbitrary and the what? And the actual dimension, and equate the what? The powers of of similar terms. So if we do that, the arbitrary dimension is m to power of what? 3a over 2, l to power of minus 2b, and t to power of c over 2 is the same thing as equivalent to, we are comparing the arbitrary and the actual now, m l square t raised to power minus what? Minus 2. Okay, that's this. So equate the powers of similar term. We look at this. This is m, or this is m. What's the power of m here? 1. What's the power of m here? 3a over 2. So 3a all upon 2 is equal to what? 1. Ordinary mathematics now. If we clear the fraction, what are we going to have when we clear the fraction? Because I want to make use of that portion of the board. That's why I'm clearing that. Okay, if we clear the fraction, we have 3a is equal to 2 times this. You know how we solve equations with fraction in mathematics. They say cross multiply, fine, or you multiply both sides by the LCM of the denominator. So here the denominator is 2, the LCM is 2. So if you multiply both sides by that, you arrive at this. We are not here for mathematics, so we are doing our physics. So divide both sides by 3, a will now become 2 over 3. So if this will actually be the dimension of what? Energy. No, it's arbitrary, but if actually we want to convert it to actual dimension now, it means that this a must be what? 2 over 3. Then we do that of b, this to this now. What we have as the power, equate the powers, we have minus 2b is equal to 2. So b becomes 2 over minus 2. That will definitely give us b. equals what? Equals minus 1. So if this is going to be the dimension of energy, it means that B will be equal to what? Minus 1. Then C, for C now, before here is C over 2 for T, and here is minus 2. So I'm going to say C over 2 is minus 2. Clear the fraction. C becomes 2 times this is what? Minus 4. So for this arbitrary dimension to be the dimension of energy, it means that A will be what? 2 over 3. B will be what? Minus 1. And C will be what? Minus 4. That's it. 3 values. Oh, beautiful. Beautiful. I believe that you have enjoyed this part of measurement, because that's the final part we are going to consider. In advanced form, there are other forms of dimensional analysis. For engineering students, they will look at different methods like the Rayleigh method, the Buckingham method. That's for advanced analysis. There are also other ones that may not be too advanced that are still related to this. For example, we must know that when you add two quantities to give a particular quantity, it means that the units of those quantities that you have added must be the same as the units of their sum. Let's take, for example, if I say this, we need to touch this, it's very important. If I say that K is equal to A plus B, then the unit of K must be equal to unit of what? A, and must be equal to unit of what? B. So if K, for example, is in Cm, it means that A should also be in Cm and B will be in what? Cm. You see that? The same thing with subtraction. If I say that P is equal to Q minus R, then the unit of P will be the same as the unit of Q and will be the same as the unit of what? R. So if I now have, let's say, someone said that force is equal to A plus C, and someone said, what's the unit of A? A is in Newton and C is also in Newton. Why? This is force, which is in Newton. So when you add two quantities to get a particular quantity, then the unit of those quantities must be the same as the unit of their sum. So if force is A plus C, then it means that A must be in Newton and C must be in what? Newton. So F is in Newton. So the quantities that you have to add to get F must have the same unit. The same thing applicable to subtraction. But if you have a product, like if I say that P is equal to AB and P is in Newton, it means that when I multiply the unit of A and the unit of B, I will have what? Newton. So the product of the two units will give us this. You see that now? Then the same thing with division. If P is maybe K over M, then and maybe P is in meter, it means that when I use, let me not use M now, and maybe P is in Pascal, right? That's unit of pressure. Then it means that if I divide these two, I will get the unit of this. It means the unit of this dividing the unit of this will give us the unit of this quantity. Very important. Very important. It's very important. So we may just take a question on that, and then we give one more question, or we'll give one more question, and then when you now solve it, we return to just cite an example on that, so that you actually understand what we are talking about. Or we'll just give a question on it and then return to solve it. So let's take our quick quiz. Our quick quiz. Number one, given that the dimension of power is mass, of mass minus 3, then length to minus 2 b over c time to minus 3b given that force F is F equals AB plus T plus K, and A is velocity, find the dimensions of B and K. Oh, beautiful. If force is F equals AB plus what? K, and A is velocity, then we are asked to find the dimensions of B and the what? K. I think that question will actually help us to illustrate that. This I is current, is one of the dimensions of current. Okay, as you enjoy your quick quiz, I need to also enjoy my break. Don't go to break, don't go for break until you have actually finished with your quick quiz. You know I'm free. I'm not preparing for this exam, but rather I am preparing you for this exam. So you are the one that is not supposed to rest. I think I need to rest now. Don't mind me. But I believe that you have enjoyed the meal so far. And if you still have problem in dimension, units and quantities, then there is need for you to contact us. You can actually send a message to our WhatsApp, or you send a message to our email, or you can also send a message to us on Facebook, which on any of these platforms that you send a message, we are going to reply you without hesitation, because all we want is that at the end of the day, you will pass your exam. We want you to be scientifically sound. We want you to be sound in physics, sound in chemistry, sound in biology, and also mathematically sound. So that when you pass, as you are walking along the road, anybody that sees you will also see physics, see chemistry, and see mathematics oozing out from your body. When you touch someone, the person will contact mathematics. You touch another person, the person will contact chemistry. When you get home and you touch your mother will now begin to speak in the language of chemistry. And when your body just touches your father will now begin to communicate in the language of physics. Oh, what am I saying? We need to go for a break, but make sure that you solve your quick quiz. We shall be back to look at the answers to this quick quiz. But before then, we shall also need to go to other topics and see what we have to offer in those topics, because we want to touch as many topics as possible to enable you prepare well for this exam. Thank you, and God bless you. Keep watching our videos on science tutorial on the YouTube page, and also our videos on mathematics made, both on YouTube page and also on our Facebook. Thank you, and God bless you.